Well, good afternoon. I'm Andy Piper. I'm from Diffblue, and I'm going to be talking to you about this catchy title, Copilot to Cover. AI-augmented coding isn't your robot overlord. So, on with the show. So, is AI going to take over programming? Well, this was a recent tweet from someone. As we know, Twitter, the source of all fount of all knowledge. To replace programmers with robots, clients will have to accurately describe what they want. We're safe. And although this is said in jest, I will come back to this because intent is a very key thing when we're talking about AI, particularly in relation to programming. So what are we going to talk about? So not strictly in this order, but I'm going to describe what AI-augmented coding actually is. And I've got a couple of demos later on, demoing both GitHub Copilot, which you probably have heard of, and our own product Cover, which you may not have, but hopefully you will know more about by the end of this talk. The different approaches to AI-augmented coding, there's sort of two main categories, two main classes. And how AI can basically transform coding. It's not that robots aren't going to take over, but they are going to have a big impact on our lives as developers. So quick bit about me. So although I run engineering for Diffblue now, my background is technical. I used to work for, well, I did a PhD at Cambridge back in the day, MapReduce, long before Google, but I didn't make any money off that, unfortunately. And then I was at BEA for a stint in San Francisco working for the WebLogic server team. I ran their sort of network high availability team for a while. Switched to Oracle into sort of the world of fast data and real-time data streaming. I then worked for a startup doing a similar thing, Push Technology, and then switched back to a big company, CBRE, biggest commercial real estate company in the world. Didn't like that very much, and so now I'm here back at Diffblue, really doing rocket science. We are pushing the boundaries of AI in software in Java. Okay, so what is AI-augmented coding? Well, this is our definition. It's principally the use of AI, and by that we generally mean machine learning, although there are some sort of differences there, to help, with emphasis on the word help developers write code. And typically the reason that developers need help is there are certain tasks that are boring, repetitive, and developers are really bad at those sorts of things. They find them tedious, they get them wrong, and just because they're tedious doesn't mean that they're important, aka testing, very important part of development, but can be tedious and error prone. So in terms of the sort of AI augmented space, there's sort of, at the moment, there's three sort of main spaces, although this is evolving very quickly. And the one you've probably heard about is Copilot. So Copilot does basically auto-completion in your IDE. Auto-completion has a long and varied history. Back in the day, the Bash shell did auto-completion in a very dumb sort of way. Copilot's a little bit smarter than that, but it's doing a similar sort of thing. It's trying to give you what you want in your sort of context, development context. And it does it pretty well, and I'll show you a demo in a bit. Then there are some other players in this space, but not that many, and I'll kind of explain why. Tab9 is another well-known one. And then there's sort of various products emerging from some of the big players like Microsoft as well. So that's auto-completion. There's also a very specific space around coding competitions. And Google has a product called Alphacode in this space. I guess it came out of AlphaGo, which was their Go solving model. And coding competitions are a very sort of rich source of being able to solve these kinds of problems well. And I'll explain why again a bit later. Both of these spaces are based on machine learning, and in particular GPT from OpenAI, various incarnations of GPT, but basically training a model and then exercising that model. On the other side, we have the sort of reinforcement learning crowd, and this is not training based, this is sort of executing AI models as you go along. We're in this space, Diffblue, AI for Code. So we have a product called Cover, which is about unit test writing. And there are a number of other companies trying to do similar things. EvoSuite is probably one of the most well-known. And then another startup, Ponycode, who were recently acquired by Circle CI. So it's a space that's moving quite quickly, and a lot of interest in this space. So let's first talk a little bit about Copilot. So Copilot is based on GPT transformers. So GPT stands for Generative Pre-Trained Transformers. Transformer is just a type of neural network. So neural networks, you may or may not be aware, they are basically models that transform inputs to outputs. And there's been various sort of incarnations of those. One of the key points about transformers is that they're able to operate in parallel. So they can take a set of input tokens and execute in parallel on those input tokens, and therefore run very quickly. So you can, when you can run things in parallel, you can put them in the cloud, you can scale them up over large numbers of compute servers and give the user the illusion of speed when in actual fact you're cranking through large numbers of CPU cycles. And here's a very simple example. We're translating English into French here. So we start with the quick brown fox and we end up with, well, my French is awful, but le renard brun. It's an iterative process, but it's also one that runs in parallel. And depending on the type of model that you've trained, that model dictates the outcome. So could be French, could be code, could be sort of more text. So they've used GPT for writing sort of abstracts and things like that. But the key point is it's natural language based. So this is all about transforming natural language tokens from one form into another. So a little bit about the origins of GPT, so Generative Pre-Trained Transformers. So it started off with a company called OpenAI. It started off with an open source model and open data, and in 2019, so not very long ago. And this model was relatively large, 1.5 billion parameters, and it was able to translate text and summarize text and answer questions about text. So that was quite successful. So then they moved on to GPT-3, July 2020, so getting really recent. Again, pre-trained model, but this time closed source, closed data, and a much larger model, 175 billion parameters. Again, able to summarize text, answer questions about text, but then able to write new text from input. Microsoft liked this so much that they gave them $1 billion, yes, 1 billion, so that they have exclusive rights to running the model. So you can't run this model yourself at the moment. You can ask Microsoft to sort of, you can hook into their APIs to access the model, but it's sort of a closed thing at the moment. And then out of that, under sort of Microsoft's auspices, came Codex, which again is GPT-3 based, focused on a narrower problem. So just about writing code from input tokens. And this is the basis of Copilot. July 21, so literally last year, not very long ago. Again, pre-trained model, closed source and data, and a smaller number of parameters, but still 12 billion, so pretty big. As I say, able to write code, particularly boilerplate, repetitive code in what they call foreign lands, which I'll describe shortly. So Copilot is trained. It's trained on open source, and they trained it on GitHub, which was a pretty smart move, but a little bit controversial because who owns the source code? And we're not going to talk about that here. We could have a whole talk about whether the rights and wrongs of training Copilot and GitHub, but that's what they did. And that training set then gives them this model. And it's worth pointing out that the model is quite expensive to train. So, you know, we in the order of millions of dollars to use the compute power in Azure Cloud or whatever. So you can imagine with a 12 billion parameter model, it takes some time to build up that model. And this is one of the reasons there are not that many players in this space. I mean, apart from the fact that Microsoft bought up the rights to running this particular model, but it is actually quite expensive to run that level of compute power. And so typically we see sort of larger players in this GPT type space. And then GitHub is also used as the test set. And the test set is sort of used to determine whether the code that you're writing is effectively correct or not. Now, because of its size, Codex has to run in the cloud. You can't run it on your laptop. There's also some controversy about that. So maybe banks don't necessarily want to ship the context of their code off to the cloud. But that's the way it works. It's just simply too large to run on a local development desktop. And the IDE essentially provides context, editor context, to the Copilot service. It does its sort of model exercising in the background and then provides suggestions back to the IDE. And this runs in an iterative process so that it can improve suggestions. And I'll show you kind of what that looks like shortly. So what is it good for? Well, GitHub themselves say that it works great for quickly producing boilerplate and repetitive code patterns. So things that developers perhaps, just get bored writing that are, it's just sort of make work to some degree. So what do we mean by boilerplate? So here's a great example, a person class. I'm sure you've all written person classes before. It's got a name, it's got an age, it's got accessors, it's got an equals and hash code, the sort of things you might get in a Java interview question. And Copilot has written all of this. And you may say, well, okay, my IDE can do that just as well. True, but usually your IDE starts with maybe the member variables here. And Copilot has done this based on the comment at the top. I don't know whether you can read that, but it says a person class with name and age accessors and equals and hash code. So that's the code, that's the input tokens that Copilot is using to then generate the boilerplate off of the back of it. Another thing that Copilot is quite good at is calling foreign lands. So this is where you want to call, in this instance, the Twitter API. So you want to integrate with the Twitter API, and I'm sure you've all spent hours on Stack Overflow and with Google just trying to get the right security tokens, the right form of the API. Copilot is really good at this. So it can basically construct, in this case, the entirety of calling the Twitter API based on the fact that you've got a function called fetch tweets from user and some token at the top there. So it's really, really good at setting up that kind of stuff that is actually quite hard to access otherwise and very error prone. And you can imagine why. A lot of the code that it's been trained on in GitHub does this sort of thing, and so it's very good at generating that sort of code. Okay, so that is Copilot, and I'll show you a demo shortly, but I'm just going to talk a little bit about Cover now. So Cover is specifically about writing tests, and test writing is a little bit harder than code generation. Not least because we want the machine to do everything. So sort of a partial job is not good enough. When people write tests, if they get a machine to write the test, they want it to be 100% autonomous. And Copilot says it's right 43% of the time. So generally the model for Copilot is that there is user interaction, user intervention. When I start writing with Copilot, you'll see that going on. It does kind of what you want, but sometimes it doesn't do what you want, and you have to sort of step in and change things. AI test writing is not very useful in that model. You want the machine to go away, write the test for you, so you just don't have to think about it. And typically with test writing, you need more context than that as well. So obviously there's types, methods, factories, that sort of thing, but then frameworks as well. Different frameworks require different kinds of test interaction. Again, there's also then the nature of the program versus the data that it's operating on. Typically, data might be in a database. You often want to mock that kind of data, and that's actually quite a hard process to get right. I mean, I think we all can know what good tests look like in that space, but actually automating the writing of that kind of setup is quite tricky. So the way that we do this and the way other products do this is sort of as a search of the possible output, so a search of the possible types of tests that you could write. So we start with all of the possible test programs, which is essentially infinite. And then we narrow that space based on tests that are valid and run. So Diffblue cover always compiles tests, always runs tests, and we will reject tests that basically don't work. So you never get failing tests, you never get tests that don't compile. And then within that space, we're looking for tests that actually give coverage. So tests that simply generate null pointer exception all the time, not very useful. So you want tests that actually exercise your code. And we will do a coverage-driven search of the space through the methods under test using coverage. And then finally, developers want tests that look good, that look right, that make sense to them. So one of the complaints about AI kind of code writing is often that it just looks like garbage. You know, you just can't understand the code at all. And so we want tests that are reflective of what a developer would expect, not only in terms of Java, but in terms of the framework that you're using, say, Spring. So this search of the coding space is done via reinforcement learning, and the reinforcement learning doesn't have a training phase. So GPT, Copilot, they have a training phase where you're training up the model based on sort of inputs it's seeing. Reinforcement learning works as you go along, and so and typically the way reinforcement learning works is that you have some kind of reward function that tells you whether you're sort of closer or further away from your goal. In this case, coverage is our main goal. Obviously, coverage is a poor proxy for test quality, but it is a measure that's easy to measure and gives you some feedback about whether you're doing well or not. And we will use other metrics as well, but coverage is one of the main ones. And so we will go around this loop where we write a test, we run the test, we get the results, evaluate their effectiveness, and then predict what a better test might look like based on this reward function. And we will keep going around that loop until we get either complete coverage or we sort of run out of time or things to try. So how might this look in a sort of real setup? So if you think back to what I said at the beginning about measuring intent, so machines can't measure intent. All they can do is sort of give you something based on the hints that you provide. And in the case of test writing, what we're doing is we're essentially testing for regressions. So we're writing tests that make sure that the program as written continues to work in the way that it is currently working. So this is sort of the definition of regression tests. And so the way that you would use a product like ours is that you write tests initially for the entire application. So you establish a baseline, so that's your regression test suite. And if anything changes for the worse, your regression test suite will tell you about it. And then you can integrate that into CI, run tests on a proposed change, find and fix bugs. So in terms of, so people typically use pull requests in GitHub. And this is what a typical pull request looks like without AI-augmented coding. You have running code with it, typically with a test suite associated with it. Someone writes a code change for that test suite. You generate a pull request, and at that point, CI kicks off and starts running the test that you have against that code change. It finishes running the tests, and the test will either pass or fail. And if they pass, then you effectively assume that the code change is right, and you can merge. If the tests fail, then you have a decision to make. Is your code correct, or are the tests correct? And if you think the tests are correct, usually they are, then you'll change your code and eventually merge. So with AI augmented coding or test writing with cover, so first of all, we have this baseline of tests that we establish at the beginning. And then that baseline is run as part of the test suite within a pull request. So within a pull request, you're running your automatically generated regression tests plus any any developer written test that you might have. And then you go through the same process. Is the change correct? So the tests either pass or fail. If they pass, then you determine that your code is correct. You'll do the merge. And then importantly, at the end of the merge, you'll update the baseline. So you're continually moving your corpus of regression tests forward. If the tests fail, then you again have to decide, is it the tests that are wrong or is it the change that is wrong? Typically, it's the change that's wrong, in which case you update your code and move forward. But obviously, there are latent bugs as well. So it could be that the tests are testing for the wrong thing. Intent is wrong, in which case you'll have to update the tests. Okay, so that is Copilot and cover. So let me just switch to a demo now. Okay. So here is IntelliJ. So I'm going to demo cover. Actually, no, I'm going to demo Copilot first because that was the order that I did it in. And I do need my glasses for this small text. Okay, so this is Spring Pet Clinic, and you can see that we've got a number of people familiar with Pet Clinic. Who's heard of Pet Clinic? Spring Pet Clinic? A few. Okay. So it's a sort of artificial app written by the Spring guys that are used to demonstrate features of Spring, and it encompasses sort of the usual aspects of a pet store, and I think veterinary practice. So it's got things like owners, it's got pets, it's got those sorts of things, and so here you can see we've got a pet here, and it's an entity type. So it interacts with the database in some way, and there's various sort of functions to access that pet. It's also got a number of tests that can be run in the background. So what I want to do is create a new type of pet, and yes, okay. So I am going to create a new type of pet called a dog. A few people here have dogs, I imagine. Okay, so I've created my dog class here, and you can see that Copilot is already suggesting extensions. So it recognizes that dog is a type of pet, so I didn't provide that information. And it's suggesting that I extend pet. So I'm going to tab complete and say, yes, I'm going to do that. Now, when I was practicing this talk, Copilot then decided to write loads and loads of code for me. I updated it this morning, and it's decided it's going to do something slightly different. So lesson is don't update the underlying software just as you're about to do your demo. But the same sort of things apply. So I can, for instance, I can say a dog. Okay, so now it's suggesting that a dog has a breed. Fair enough. Okay, I will go with the dog breed. And so Copilot is interacting in the background with the cloud service, say, okay, so it's suggesting that I have a weight. So it knows something about dogs. It knows something. So it's doing natural language processing of the word dog and what that dog actually means based on the context I'm providing. Okay, so I've got some member variables there. So now it's suggesting that I'm going to create a constructor for it. Well, that seems pretty good to me. Okay, so I shall create a constructor. And oh, now it's going to suggest another constructor with some extra parameter variables there. Looks good. But you can see, okay, so now you can see some of the issues here. So this is, although it's providing context, there isn't actually a super constructor in pet that takes a string in this way. So although it knows some of the context, it doesn't know all of the context. And so it's starting to write code that won't actually compile, which is a little bit annoying. So, okay, so I'm going to delete that, start editing it so that, because IntelliJ knows. Okay, get breed, I'll go with get breed. That seems pretty good. And then it's probably, okay, so it's going to mutate. So you can go on like this. I'm also going to write a toString method here. And, oh, there we go. So it's now decided that the toString, whoops, sorry. So it has to go back to the, make sure this is public. There we go. So it's now suggesting a toString method based on the mutators and accessors I've got beforehand. Okay, so now you can see another error there. So I haven't actually, did I actually create get weight? Yeah, okay, so there's no accessor for weight. So it's assuming that there's a get weight accessor. It doesn't actually exist. So if I try and compile this, I'm going to run into problems. So I'll get rid of this, make it compile. Okay, oh, it still wants me to do get weight, but I'm not going to do it. Okay, so that sort of gives you a feel for what Copilot can do, and you can do other things like say, add comments and say dog has, and it will even complete some of the comments. Okay, a name, a breed, and a weight, so it knew that already, and those sorts of things. So it's quite good at processing language tokens and then turning them into text. I think as a sort of a developer productivity enhancer, it's pretty good. But it also sort of exemplifies why being 43% right can be a little bit annoying. So you sort of start to write code and then it does the wrong thing and then you have to go back and delete it. So it's good. It's good when it's suggesting what you want. Slightly annoying when it's not suggesting what you want. Okay, so that is Copilot. So let me just move on to cover. Okay, so this is owner controller. So and what I'm going to do, just because it all runs, so Copilot's running in the cloud, it's interacting via the Wi-Fi with the cloud service. Diffblue Clever all runs locally on my laptop here. So I'm going to kick off the test writing process for owner controller. And while that's going on, I'll sort of explain a little bit about what's going on. So owner controller is a Spring controller. So it assumes some context around sort of web services and REST and those sorts of things. You can see that there are various Spring annotations. So there's a repository here, which is a Spring type of thing. And then you can see there's various Spring annotations which imply some behavior for the methods in this class. And so if you were to sort of just treat this as a plain Java class, you wouldn't get very far in terms of writing useful tests. You need to know something about what the annotations are in order to be able to write effective tests that a developer would find useful. So what this is doing in the background is analyzing the bytecode in particular. So we function off the bytecode, so we have to have a built product to start with. That's different to Copilot, which is functioning off the source code, the natural language tokens. And what it's done is it's discovered all of the methods in this class, and it's trying to write tests for them. And I'm not going to add these to Git, and you can see that process has now started. And so what goes on is that we do this coverage-driven search of the test space by providing inputs into the methods. So the engine is trying to, for instance, init creation form, it's trying to find a map type input that will generate useful outputs and will generate coverage for the method. Not actually that hard because it's just, there's no sort of branch paths here. And I think you could probably, you couldn't pass null into this because then you get an MPE, but as long as you pass some kind of map, it's probably going to work okay. Okay, so we've nearly completed the test writing there. Okay, so there we're done. And just to prove that it is 100% correct, I'm going to run all of the tests. Oops. So this is running all of the tests in Pet Clinic, the ones that the Spring guys wrote, which is already part of the project, and then the ones that I've just written using Cover. And there it's done. One of the main things about unit tests is they run very, very fast. So they're supposed to run fast in CI, and they allow you to sort of iterate very quickly. And you can see that the tests that I've just written, which are owner controller test, there we go, here. So they all passed. So if I look a little bit more at what's been generated here. So here is owner controller test. And let me sort of switch back to owner controller so you can see. Okay, so here's a method, process creation find form. Sorry, process creation form. And you can see that there's sort of a couple of different code paths here, and we want to make sure that we get complete coverage. And so Cover has been exercising different inputs into this method. It knows about sort of mappings here, so it knows how to generate the correct data. And if we look for creation form here, let's switch back to the tests. Okay, that's find form. Here we go, creation form. Okay. So here you can see that we've basically got 3 tests generated for creation form. Test process creation form 2, creation form 3, generating 100% coverage for the method. I think another couple of things to notice are, obviously you've already seen it compiles, they already run, they pass. We've got data that looks vaguely plausible. So a little bit like GitHub Copilot is trying to anticipate things that should work. We're building things with addresses in, because that's what the test wants, telephone numbers, and then the data looks plausible. But another aspect to look at this is it is a true unit test. So we're using mocks here to build up the scaffolding of the test rather than having to interact directly with a web server. And this is why these tests can run very, very quickly. Now, you know, people will want integration tests as well as unit tests, but typically a lot of the value comes from a large corpus of unit tests. And you can see that's just written it for the entire class. Okay, so back to the slides. So just to re-emphasize, Cover is good for 100% autonomous Java unit test writing, and it's good for test maintenance. We can also write skeleton tests for things that are untestable. Someone asked me about whether we have a notion of testability, and we do. So certain methods will be annotated as not being testable. For instance, private methods is a good example there. And we're able to generate sort of partial tests for that sort of stuff. And then we also have some dashboarding technology to show how coverage is getting on, how testability is getting on. And in the future, we're going to get into sort of refactoring and that sort of thing. Okay, so that's code completion, test writing, a little bit just around coding competition. So this is DeepMind Alphacode is the sort of well-known example of this. So not very long ago, everybody was saying DeepMind Alphacode, developers are redundant. Is AI ready to replace programmers? This is literally February of this year. Hit the technology news. And the truth is, no. So the thing about coding competitions is that the outcome is very, very precisely defined. You know exactly what it takes to win, or not what it takes to win, what a winning solution looks like, because typically there are tests that exercise that solution. So coding competitions are a very, very narrow space here because they are so well defined, and that doesn't really represent the real world. I know we kind of wish it did, but in actual fact, intent is very, very hard to measure often for commercial code. But it is still an interesting space. So how does it work? So Alphacode is also transformer based, so it's using GPT, and it's trained this time on public coding competitions. And that's used for generating the model. But also it can be validated on the unit tests that these coding competitions typically set up as a means of determining whether you've succeeded or failed. So the way it writes code is a little bit like Cover. So it's doing a search through the space of solutions. It starts with this clear, unambiguous description of what the code must do. It uses transformers again to generate hundreds of possible solutions, too many to be evaluated. And so what it does is it then does a sort of clustering algorithm. So it takes those solutions and it finds ones that are essentially semantically the same and boils those down into one of the solutions that it's going to try. Ends up with tens of possible solutions. It then runs the unit tests on those, and that will say whether you've succeeded or failed. And of course, you only need to succeed once. Once you've passed the test, you've won the competition if you're first. And it works pretty well, and it's able to beat programmers. I think it's like 50% of the time or something like that. So in this narrow space, very, very effective way of using AI. So like I said, it's a little bit like Cover in that it's doing a sort of a search through the space of possible solutions, picking the best ones. But you can't buy it. It's only within Google at the moment. They're only using it internally, so there's no way of trying this externally. It doesn't work all the time, so sometimes it passes, sometimes it fails, and a little bit like in the way that Copilot does. And it's more of a demonstration of future potential. So again, they're just getting started. These things are going to change very rapidly. And I would expect to see more from DeepMind shortly, I would guess. So in summary then, AI-augmented tools are real today, and in particular, they help eliminate some of the tedious aspects of development. Both tedious and error-prone. And the error-prone piece is very, very important because, as we all know, bugs are much easier to catch early in the process as things get left in later in the process. If you don't catch them early, it gets very, very expensive. And so eliminating the error from some of these tasks can be a very good way of saving money. Now, all the leading tools that you can get hold of have free editions. We have a free edition. You can get it from JetBrains Marketplace. Copilot, again, is a free preview at the moment. Again, you can get the JetBrains plugin, the IntelliJ plugin, from the marketplace, but then you have to sign up and wait. I'm actually using someone else's ID because I signed up a couple of weeks ago, and I'm still waiting for the yes, you can use this thing. But there is a free edition there. But I think the other thing to notice is this is the start of something big. These are tools that have legs and can generate real value for developers. Yeah, watch this space. So we're Diffblue. We're actually on a stand downstairs, G5. Visit us down there or see our website, diffblue.com. And if you want to try out the technology, there are free versions on our website. There's a free version of the CLI as well that you can try, which is what you'd need to integrate into CI. And thank you for listening. So any questions? Oh.
So with regard to the reinforcement learning that you're using in this cover product, so how does it actually because obviously it works through a reward versus penalize process, right? So how does it know when to reward or how to reward, etc.? Can we, as developers, can we configure, or does it come set with the
You mean for Copilot or for Cover?
cover? Yeah.
For Cover. So you can't configure that aspect in Cover. It's sort of all built into the machine. We are on a constant quest to make things better and sort of make sure it's reflecting what developers want from a testing perspective, but it's not currently configurable in that way.
And does it actually start training itself, like when you start to generate the test cases, or does it already start with a model and then builds on top?
So the model restarts every time you say, write me some tests, and it doesn't sort of learn based on the test that it's actually written, but it does learn based on the code that it's analyzing, and as it sort of builds up an internal model that it learns based on. Does that answer your question?
It does. Okay, thank you.
I mean, if you want to ask more details, come and visit us at the stand. The CTO is here and many other technical people. So,
okay, thank you.
So, I guess two related questions. So, does Cover assume that your code is correct when it generates the tests? And what does that mean for test-driven development, like in terms of if you're using Cover alongside it?
yeah, good question. So it does assume that your code is correct because we can't measure intent. So there is no way to measure intent. But regression testing is everybody does regression testing. That's the only way you can make forward progress in a project. How does it relate to TDD? So it's complementary to TDD. So typically with TDD, you are developers are writing tests and then writing a subset of tests, I would argue, and then they are writing the code to reflect that subset of tests. Cover then can then fill in the blanks. So if you write, I don't know, 30, I don't know what percentage people use, but maybe 30% with TDD, we can write the other 70% based on those sort of typically more happy paths that the developers focused on versus the complete coverage, which is what you want for a unit test corpus. One at the back.
Sorry, thanks for the talk. It's been really interesting. I was just wondering, in terms of refactoring and naming, I was just wondering how Cover does it appreciate like when the test goes green, for example? Does it think about, is it following the best practices, and does it refactor? And does it consider naming when the problem is being phrased?
So it considers naming in the sense of test names reflect method names. And we're looking at ways that we can make the names, because typically what people want, they want the name of the test to reflect what it's doing. That's quite hard, but there are some simple things we can do there that, like does it throw an exception, does it pass, those sorts of things. So at the moment, the naming is based mainly on the method under test. In terms of refactoring, we have some initial support that we're looking around refactoring. There's some very basic things. So, for example, typical example is you saw in the spring demo, we use mocking. So if you're going to write a good test corpus, you need to use mocking because you don't want to sort of be running up a database or a web server or whatever all the time. Often people don't include the right mocking framework in their Maven setup or their Gradle setup. And so one of the things you always want to be able to do really is refactor the build configuration to add those in. So that's one of the things that we're working on. And similarly on the Java side, we're looking at some refactorings that we could do, for instance, making things private to public or, that sort of thing. Question here.
I'm assuming behind the scene we might be using Mockito to write the unit test cases. But what if Mockito itself comes with the new versions and it has a new set of API, etc.? So will this
Yeah, so
write
we
the code on top of it, or it requires more enhancement to support the new frameworks?
so we make every effort to support a broad range of the types of framework that you might be using. So JUnit, Spring, Mockito are good examples. So we support older versions of Mockito. I can't remember what version we go back to, 1.2, I want to say. And now we're on Mockito 4.7 or something. So we support a broad range of versions of Mockito. Yes, sometimes people make breaking changes. I think Mockito 4 was a very large change from Mockito 3, and we had to make some updates to that. But we've done that and support that. And JUnit and Spring are similar. So we make sure that we support the latest versions of things and in a compatible way going backwards. Any more questions? Oh, one here.
Do you plan to support anything else than Java?
Than Java? Good question. Eventually, yes. I think the easiest candidates are JVM-based languages, so things like Scala, Kotlin, that sort of thing would probably be next. People do ask about C#. That's harder because it's essentially an entirely different, different model. But yeah, certainly. There's enough of a market in Java at the moment for us to focus on, but we will get there eventually. No more questions? Good. Thank you very much for your time.